time. Okay, it is time independent analysis, like whatever we are applying the loads on the object, like thermal loads, so it is not affecting due to time. That one we can say as a steady state thermal analysis. Okay, here you can find some terminologies are there. What are those in every time we will discuss. Here we have one problem. Okay. So what we will do, we'll do a simple problem. Okay. Then we will go for some this one. Okay. First of all, I am creating one component here. I am taking an example of pipe. Okay, now see here guys, I have some 300 pipe. Okay, creating some cooling things here. Very versatile. Right. Switch here. Okay guys, now see here, this is my component. Okay, file, save as, save this one to HTTP format, and on desktop give the name as okay. Like that, I have one problem with me. Now go for Ansys. Take here, you can find the steady state thermal analysis is there. Just go there and change the material to copper. It's a copper material. Usually in thermal we are using copper material only. For engineering data, general materials, copper alloy. Copper alloy. Material assigned here, close this one. Now go for right click. Just to go for design modeler, there we will import. What is the difference between, I will show one option there. What is the difference there, you will come to know. File, import external geometry. When here guys, if I am generating by taking this one as add material, generate. So what happened here, when I am selecting these spaces, this one is selected separate space, this one selected separate space. So it is creating two spaces here. If I want to make that one a single space, so what you have to do is here you can find the option like simplified geometry and simplified topology. Just make those two things as S. Okay? Simplified geometry and simplified topology, if you do both the things, if you make as a yes, and if I click generate here, now here it will come as a single space. So what happened, those spaces are creating separate spaces now, that will become as a single space. Okay, for that purpose we are doing that. Both the things we are making yes to perform this thing. Why? Because while applying the boundary condition, sometimes what happened, we cannot able to select the spaces here. So in that case, if you make it on a single space means you can able to easily select a space. Okay, now see here my geometry has been assigned here. Now close this one. Now go for the model environment. Now see here my geometry has been imported here. Now first thing is geometry, we have to check and change the material to copper alloy. Okay, then generate the mesh. Mesh has been generated. If you want some fine mesh, you can make here. Okay, the mesh also has been generated here. Now go for this one. Why? Because we are not performing the thermal, like what you can say, transient thermal. We are performing static. So don't do anything, just to go for assigning the boundary condition. So here, for example, this is my pipe. So what I am doing here, I am passing a hot water from this pipe. Okay, I am passing a hot water from this pipe. So for that one, what you have to do, see here we can find some terminologies out there. Okay, some terminologies you can find here. You have to understand it. See here, in thermal analysis, you can find three things out there. The first one is conduction, convection, and radiation. Okay, conduction, convection, radiation. So what is conduction? Can anyone tell me? Conduction. Anyone?
Transfer of heat.
Transfer of heat.
Transfer of heat when two solid bodies are touching each other.
Yeah. Conduction means if the bodies are in direct contact and the heat is transferring from one body to another body. That one we can say as a conduction. I will take an example here. Suppose for example I have two bodies here. Right. Okay. Like the two bodies I have here. Suppose for example this is your A body and this is your B body. Okay, A body is there and B body. If the body, if the temperature, if the heat is transferring from body A to body B, if they have the physical contact between those two bodies, that one we can say as a conduction. The next one we can find here is convection. Can anyone tell me what is convection?
Transfer of heat from cold region to hot, from hot region to cold region through a fluid.
Yeah. Okay. Convection means transferring of heat from one location to another location by using some fluid mechanics. Okay, by using some fluid, we are moving, like the heat is transferring from one location to another location. That one we can say as a convection. So what is the third one? Radiation. What is radiation? What is radiation? What about the other people here? You are not saying anything. Radiation. What is radiation? Anyone? What is radiation? Nothing is a transfer of heat from one body to another body by electromagnetic waves. Okay, by electromagnetic waves. That one we can say as a radiation. For example, we can take a simple example here. Suppose for example, if you are boiling water. Okay, if you are boiling water, the bowl will keep on stove, for example. So bowl is a different body and handle is a different body. So when we are heating the bowl, automatically the handle also get hot there. That one we can say as a conduction, means from bowl to handle the heat is transferring. Why? Because they are in direct contact. The water which is present under the bowl, it gets heated and it will make a like it will evaporate. That one we can say as the heat is transferring in the other environment by the help of fluid. Like by help of fluid, it is transferring here. So that one we can say as a convection. The next one is the heat, the fire, whatever we are saying, that is we can say as a radiation. So like that we can able to see the differences between conduction, convection and radiation. So say here my fluid, like my fluid, like what I am doing here, I am passing hot water from here, from this pipe. Okay, so what happened when we pass through a hot water from this pipe? What is the what we can say, temperature will get the total temperature for the whole body, and we'll say different things. Okay, so first of all what I will do, I will take, I said hot water means it is a convection. Okay, flowing of heat through fluids. So right click on that one, insert, take here convection. go for convection, select the geometry, this one. Okay, select the geometry, apply. Now see here guys, here defining here film coefficient. What is here? Film coefficient. Film coefficient. What is film coefficient here? Anyone? Here film coefficient means it's actually a proportionality constant between heat flow and change in temperature. So here how much heat is flowing from this body to what is the change in temperature we are getting. The ratio of those two things we can say as a film coefficient. So film coefficient is heat flow or heat flux by change in temperature. That one I am giving like 20 degrees centigrade. Okay. Ambient temperature. See here, the heat is flowing from this body now. What I said, hot water is moving from there, right? Convection. So how much temperature of the water is there? I am giving some 100 degrees centigrade now. Okay, 100 degrees centigrade is passing through this pipe. Okay, the next thing is I have to see here. These are my fins. These fins are connected. See, like the surrounding temperature affecting these fins. Touching to this fins, due to which the temperature is going to change here. So for that reason, see here, surrounding temperature means here we can get radiation. So what you have to do, again go for analysis, insert, take the radiation on these spaces. Select all the cases here. By pressing Control select all these spaces, because it is connected to surrounding, so we have to specify the radiations for this one.
Sir, I have a doubt.
Yes.
Sir, in the geometry itself, can we select all these surfaces and unite them and make it as one thing? So while selecting here, we can do it at once.
Like it is not the modeling software, yeah. Usually.
Oh.
Yeah.
Okay. Okay.
It's a analyze software. Why? Because just now I shown you the thing, topology. Initially it is selecting this as the two faces, but right now after that one it is setting as a single face. So it's somewhat difficult here. Here I have some macros are there. So by using those macros also we can able to select here. But that one nothing is, just go for tools. Run macro is there. There you can find some, like what is macro here means. Some option is there, macros. So under that one some programs are there. So with the help of that programs we can able to select the faces. Suppose for example if the faces has same sizes. So at that time if you select one and if you run that macro, automatically all the faces are going to select. If you run that macro. Okay. Now see here, I have selected this thing. Here emissivity. So what is emissivity here?
Amount of radiation emitted.
Yeah. The amount of radiation is emitting from the body. That one we can say as a emissivity. So emissivity I am taking like, for example, 0.25 as my emissivity. Ambient temperature means surrounding temperature, how much we require. Why? Because I am taking the radiations here. So radiation means surrounding temperature or environmental temperature we can say here. I am taking this one as 20 degrees centigrade. Okay, 20 degree centigrade. Now see here, my input has been done. Now what we have to do, we have to check the temperature, overall temperature of the body after performing this one. So go for temperature we have to find. Then I am finding here, for example, total heat flux, means how much heat flux is happening, like heat, how the heat flow is happening here. These two things we have to find. Just click on solve. Now see here, it gets solved here. Yeah, temperature maximum is 100, and where we are getting the maximum temperature here, you can find here. I will remove this thing. Okay, we can able to see where is the maximum temperature we are getting here. See here, maximum temperature we are getting at these locations. Okay, somewhere here I am getting the maximum temperature, and minimum temperature I am getting on the pins, like that. That is, and we can able to find with the probe option at that particular point how much we are getting the temperature, like that. Okay, so like that we can able to do the find the temperature, overall temperature of the body when the heat is flowing from that pipe. Okay, the next one is heat flux. Okay, heat flux here, how much the rate of flow of heat here per unit area. Okay, heat flux is the rate of heat flowing per unit area, we can say as a heat flux. The heat flux we are getting here is 0.002 maximum. And we can able to check here internal temperature also by taking a sectional view. Take the sectional view here. Here also you can find it. Right. If the temperature is coming inside of the phone, we can able to check here with the help of it. And at these locations, whatever the temperatures we are getting, usually you will get 100 only. Sometimes what happens due to the radiations and all those things, it will get increase or decrease the maximum temperature for the body. Okay, so like that we can find the flow. Understand, guys? Have any doubt, you can ask. Anyone has doubt?
No, sir.
I will explain you one more problem here. Okay. What happened, guys? No one has doubt.
No, sir.
Okay. Then we'll proceed for the next problem. I will create this body here. Here we have three bodies out there. The top body is say processor material, which is natural density, specific heat, thermal condition. And the next one is copper isolator, for the most of the properties as mentioned here. And the next thing is aluminum heat sink, but that one also it has mentioned some properties. So we have to take this one, and it is saying that for a steady state thermal analysis, we consider a system composed of a processor who is mounted on a copper isolator, which is in turn mounted on a aluminum heat sink. It is saying that these are mounted on each other. The processor generate heat, means the process which you are seeing here, it will generate the heat, and the system also receive heat radiated by other nearby components. Here we have some system which is present here. They also receiving that heat, whatever the heat is there. These components also receiving that thing. The whole system is fan cooled, means the complete system is fan cooled, means we can say as an ambient temperature, atmospheric temperature we can take here. The steady state thermal analysis of the system must be less than 100 degrees centigrade. So the temperature of the system should be less than 100 degrees centigrade. Means whatever you want you can take here. The heat is here. Equivalent heat flux due to radiation from other devices. Okay, first of all, we will create the geometry here. The unit has taken as inches. Tools, options, units to be inches. It's not inches also, it's meter. Yeah, it's not. So change the unit system to meters. Okay, it's on display. It has mentioned as from here to here 0.025. Then 0.075 from here to here. Then the next thing is 0.0125. Then the next thing here is 0.0175. last one is 0.0. Wait a second, guys. I will be back in 2 minutes. Yeah, sorry, guys. Now see here, just create the geometry here. The height from here to here it's mentioned as 0.03. Okay, then the next thing is the height is 0.04. Make these things mirror. On the other side and create the line. This is the workbench. Thickness randomly, it's not mentioned properly, so we will take randomly. Bag, extend 0.01. Okay, on this space, one more sketch I am creating. Thing is there, just to project this thing. Exit, tag. What is the height it mentioned in here? 0.0025. It is a kind of assembly guide actually. Assembly drawing. Properly here. Let's check once. Here on this space, I have the source body, which creating the forces. Let's say, what is the height here? 0.007. File, save as IGL static void line, thermal 2, go for steady state thermal analysis. Material, I want the same only, I'm taking from here directly. Okay, now go for geometry. Actually, we require the different materials, na? Yeah. Wait a second. We require the different materials here, so I am not taking here. Here we have 3 different materials are there. Okay, processor, isolator, heat sink. So go for engineering data. Engineering source, just take an copper alloy. Okay. Take copper alloy I have taken. So that copper alloy only. I want copper alloy, duplicates of copper alloy I will take and give the different names. Duplicate. The first one I am taking like, for example, conductivity. Processor. The next one is isolator. And third one is heat sink. Processor, break the link from the source. What is mentioned here? Specific heat and thermal conductivity is 50,000. Okay. Taking. The next one here also I am breaking the link. So this one value like for the isolator thermal conductivity is 393. Okay, break the link for heat sink thermal conductivity is 156. Okay, these 3 things we have to specify. Then close your engineering data, go for right click, go for design model first. Then we will check how the bodies are there. Whether it's coming separately or not, we have to check here. File, import external geometry, open, generate. Body, why it's coming this way. File, import, thermal to add material, generate. Yeah, 3 different bodies came here. First body, second body, third body. So we don't require any assembly file here. So right now it's coming. So close this one. Go for mechanical model environment. sequential before processing engineering data. Engineering data is not good here. Okay. Processor. Into the proper thermal conductivity. 50. Yes. Now go for model. Actually, what happened? The property got break there. We don't not making. It is showing some errors. So we have to always check the errors what we are getting. Then only we can come to understanding that what to do. Now see here I have this geometry for different body, different material we have to specify. The first one is this one is heat sink. The next one is this one. It is like copper alloy. Isolated. And the last one is process. Now see here I assign the materials for different bodies here. Then contacts are like contact only be required. Now see here when you have the different bodies, now here we have to specify the like what we can say connections between those two bodies. So all are contact only. We don't want to change anything here. It will automatically come. Sometimes we have to create, generate mesh. Mesh has been generated here. If you want some fine mesh, we can make here. Update the mesh. Okay. After generating the mesh, we have to assign the boundary conditions. Insert, I want to specify. It is saying that we consider a system of composed processor who is mounted on a copper isolator, which is in turn mounted on an aluminum. The processor generates heat. Means the processor is generating the heat. So that is like power. How much it is generated. That thing we have to specify here. So right click, insert. I have to specify here power.
Temperature.
Temperature. Oh no. Heat flow will take. Okay. Heat flow and from the just select the spaces. How much heat is generating here? It is 20 watts. Okay. 20 watts it is generating here. The complete geometry is having fan cooled. The whole system is fan cooled. Okay, so that thing also we have to do. That is our radiation. Insert radiation. Select the whole system is a fan cooled. Apply emissivity. I am giving like 0.19 only. Then ambient temperature we can give 20 or 22, whatever you want. Okay. Then click on solve.
Sir, we haven't given the thing what it needs to be solved.
Yeah, we can give later on.
Okay.
Now we can able to keep whatever the results we have to find. What we have to find here, then determine temperature distribution in the system during steady state operation. What is the following material? It's the following material. So we have to find the temperature distribution between the bonds. So go for insert thermal temperature we have to find. Right click, evaluate this. Now see here, for body 1, like we are getting the maximum temperature in body 1 because it's a source. That is of 328 degrees centigrade. Maximum temperature we are getting on the heat source. So whenever it's coming to bottom side, the temperature is getting decreased here. I want to check the temperature of, it is asking for different bodies. Determine the temperature in the system. It's asking for the complete system. We can find the individual. Right click, insert thermal temperature. I want to find for this body. Apply. So for these bodies, so individual bodies also we can find here. So for that, on that body we are getting the maximum temperature as 321.69 degrees, which is somewhere at these locations. Okay, at this location I am getting the maximum temperature. Why? Because our source is placing at this location only. The next I want to find for the bottom one, insert temperature, thermal temperature for the bottom body, apply, evaluate. So for bottom body also we got some temperature, that is 321.39. For that system is 321.69, and this is the total temperature, like this one only, like that is 328.48. So like that we can able to find the temperature of the different bodies due to that heat flow. Now how much heat is flowing you can find here by taking the heat flux option of all bodies, apply heat flux. In which direction I want, in all direction it's not taking, I will go to total heat flux. So total heat flux I am getting like 0.13672, means heat is flowing per unit area is 0.13672 watts. Heat is flowing per unit area. So like that we can find the results. Understand, guys? Understand, guys?
Yes, sir.
So it is saying that the system, the steady state temperature of the system must be less than 100 degrees centigrade. Means whatever temperature we are getting, that should be less than 100 degrees centigrade, but still we are not getting that. Okay, we are not getting the temperature. So what we have to do means, here it mentioned forced convection from cooling fan at high speed. So this thing we can able to specify here. Convection we can able to specify here, heat flux also, to reduce the temperature.
Sir, one more thing, one doubt.
Yeah.
So for all the three things, have we assigned the material as copper?
No, different materials here. We change that radiation value now. What we can say? That value we changed here, thermal conductivity.
Yeah.
Okay. Different materials we assigned now. Like for part, this one we specified heat sink. For this one isolator. For this one phosphor. We change their values there. We have taken copper only, but after changing the values, it will not remain copper completely. So we assign different materials. So like that we can able to find the results. If I do one more thing here,
No, because
yeah, tell me.
in the problem, those forks kind of thing, and the materials given as aluminium zinc.
Aluminium
Zinc.
yeah, but that one it's mentioned the properties at the bottom side. Material property it has mentioned here. So based on that one, it's mentioned here with the following material property. If it's aluminium heat sink means you can take direct aluminium. Okay, it's not the issue. Here it's mentioned as copper, here it's mentioned aluminium, and it's mentioned phosphor. So for that one, it's mentioned some values here. These values we have to take. If it's not mentioned, whatever material name it's mentioned there, you can take that one. Okay?
Okay, sir.
Any doubt here?
Now it's less than 100. Sorry, you are on mute.
Okay. Now see here guys. Now after this problem, you try this problem guys. 16th one. Nothing is there, just you have to create these 3 cylinders with pins and assign the boundary conditions with that one. Take the materials here. Material properties also mentioned here. And dimension also is mentioned here. Now we have to find the results here, like what are the temperature is generating between the systems. Okay. Any doubt guys? Anyone has doubt?